Hello. So today we're going to talk about derivatives of inverse trig functions, and we talked about the derivatives of trig functions last Wednesday. So those were covered in class last Wednesday, and our six trig functions are sine, cosine, tangent, cosecant, cotangent, and secant. And today we're going to find the derivatives of the inverse trig functions. So hopefully you remember that each trig function has an inverse function, and where they're written like this: sine inverse of x, cosine inverse of x, tangent inverse of x, cosecant inverse, cotangent inverse, and secant inverse. And something to note is that remember that if f of x and g of x are inverses, then the domain of f of x is equal to the domain of g of x. So that's one thing that's true. And another thing that's true is that the range of f of x is equal to the domain of g of x. Okay, so we get the domain and range of our inverse functions by looking at the domain and range of the original trig functions. Okay, so now let's do an example. So our first example here is going to be, we're going to do an example of just evaluate sine inverse of 1/2. So essentially we're saying f of x equals sine inverse of x. So find f of 1/2. Now, sine inverse of 1/2 is the angle which satisfies sine of the angle equals 1/2. So a way to say this would be to say sine inverse of 1/2 equals theta, means sine of theta is equal to 1/2, and theta is in the domain of f of x. So let's actually go back and put in some information about what is the domain of f of x, which is equal to sine inverse of x. Well, the domain is restricted to be, the domain is negative pi over 2 to pi over 2. Okay, so look, going back to our example, we've got f of x equal to sine inverse of 1/2, and sine inverse of x, and we want to know what f of 1/2 is. So let's go to our unit circle. And now in our unit circle, we need we need to answer this question: sine of what is equal to 1/2, right? This is what we're looking for. This will be equal to f of 1/2. So what do we have here? Now the sine values are in the y coordinate. So looking around, we've just got 2 times where the y coordinate is equal to sine. So that means we've got this angle here, pi over 6 and 5 pi over 6. So question mark equals pi over 6 plus 2 pi n, or 5 pi over 6 plus 2 pi n. But now remember, we have a restricted domain. Remember, our domain is negative pi over 2 to pi over 2. So that is essentially the same as, let me try to draw it here. Negative pi over 2 is, right, is this angle right here. This is negative pi over 2. And so if we can go all the way from negative pi over 2 to pi over 2, that means we're looking at any values that are in the right-hand side. So when we're looking at question mark, the only value that's going to satisfy it is pi over 6. So let's go back to our notes. And f of 1/2 is going to equal pi over 6 because this is the only angle in the domain negative pi over 2 to pi over 2, which satisfies sine of that angle equals 1/2. Okay, let's do another example. Example number 2, which is going to be to evaluate cosine inverse of negative root 2 over 2. So now, the domain for cosine inverse, so maybe I put this in a different color. The domain of y equals cosine inverse of x is, what is the domain? The domain is going to be, I'm just looking at my notes here, 0 to pi. Okay, so we need to find, so our goal is to find the angle in the domain, which is this interval 0 to pi, such that cosine of the angle is equal to negative root 2 over 2. So let's go back here, back to our trig cheat sheet. We need cosine of the angle to be equal to negative root 2 over 2. So let's write down our requirements. So we need cosine of the angle to be equal to negative root 2 over 2. And we need the angle to be in between 0 and pi. So now for us, in between 0 and pi means
it's 1930.
We've got from 0 all the way to pi. So anything in this top half, in this top hemisphere, is a candidate. And now for the cosine of angle to be equal to negative root 2 over 2, cosine the first coordinate. So I'm looking around and negative root 2 over 2, bam, this is the only one. So our answer is going to be that the angle should be equal to 3 pi over 4. So let's go back to our notes. So cosine inverse of negative root 2 over 2 equal to 3 pi over 4. All right. And let's do one last example. This last example, this is going to be example number 3, is going to be to evaluate tan inverse of the number 1. Okay, so now let's put in here the domain. Now, you can find the domains for all of these inverse functions on your Paul's notes. You can also find the domains on the cheat sheets. If you go to the website with the Paul's online notes, there are downloads. You can download all the PDFs of the assignments. There are of the assignment problems, of the practice problems. You can download all of the lecture notes, right? And so you can just have like a PDF of the textbook. You can also get cheat sheets. So you can get a cheat sheet for calculus, for pre-calculus, for trig, for, for a lot of stuff. Okay. So, but just for record here, so we'll say for f of x equal tan inverse of x, the domain is negative pi over 2 to pi over 2. And this time it is open interval. Okay. So now we want tan inverse of 1. So we're looking for an angle And we need for the angle to be between pi over 2 and negative pi over 2. And we need for tangent of the angle to be equal to 1. So let's go back to our units. Now we need from pi over 2 to negative pi over 2. So I'm going to use a dotted line to show that these are not included. And you can go all the way up to pi over 2. And we need for tangent to equal 1. So now tangent of angle is equal to 1. And remember that tangent is equal to sine over cosine. So tangent of theta is equal to sine of theta over cosine of theta. So what this means is we need the x-coordinate and the y-coordinates to be the same. And we're able to look at any value, any of the values on the right hemisphere. So the only time that it looks like this is the only time right here. Okay. And so pi over 4. Pi over 4 is our answer. Okay. So tan inverse of 1 is equal to pi over 4. I guess I should have been putting little boxes around these. Okay. Let's put boxes around these. And got a little box around this. One. Okay, good. So now we've done that review. Let's jump straight into calculating or deriving the derivatives. So, okay. So now our current goal is to determine the derivative with respect to x of sine inverse of x, right? So we want to come up with a formula for the derivative of sine inverse of x. Now, in order to do this, we're going to use that fact from, I believe I used this fact in a previous video, the video for the exponential and the logarithmic derivatives. And the fact is as follows. So let me put in a different color, green. So just say here, recall. The if f of x and g of x are inverses, then g prime of x is equal to 1 over f prime of g of x. Okay, so what do we know? In our case, we know that sine of x and sine inverse of x are inverses of each other. So we're going to let f of x equal sine x and g of x equal sine inverse of x. Then clearly sine of x and f and g are inverses. So g prime, which is what we want, g prime of x is equal to 1 over f prime of g of x, right? Now, what is f prime of x? Since f of x is equal to sine x, f prime of x is equal to, what's the derivative of sine? Cosine. Cosine of x. Good. So this is going to equal 1 over cosine of g of x. And now what is g of x? Well, g of x is sine inverse. So we'll have cosine of sine inverse of x. Okay, now we can come up with actually a better or an easier formula here. So far we have that g prime of x is equal to 1 over cosine of sine inverse of x. Okay, and now remember g of x is sine inverse of x. So really we can write this as d dx sine inverse of x is equal to 1 over cosine of sine inverse of x. Now we're actually going to simplify this, and let me show you how. First thing I want to do is I want to draw a triangle. So a right triangle, I'm going to use this right triangle to help me figure out what's going on. Figure out how to simplify this. So now let's see here. So now I'm going to say, now remember, sine inverse of x is, what is that? Sine inverse of x is the angle satisfying sine of the angle equals x. So I'm going to replace angle with just theta. Okay, so if I replace the angle with theta, now I've got sine of theta is equal to x. Now, typically, in a right triangle, theta goes here, or you could have theta up here, but I just like to put it in the bottom corner here. So now if this is my theta, right? So if I have theta is equal to sine inverse of x, so if theta equals sine inverse of x, then sine of theta is equal to x, right? And that's the same thing. I can write it as x over 1. Now, sine of theta is opposite over hypotenuse. So this becomes x, this becomes 1. And I need cosine of sine inverse of x. So this is going to be cosine of theta. Okay. Well, now what is cosine of theta? Cosine of theta is, and I can use my picture to determine cosine of theta, is going to be adjacent over hypotenuse. Now I know my hypotenuse, my hypotenuse is here, my adjacent is here. So the question is, what is this? In order to figure out how long this is, what is the length of this side, right? That's the question. I can use the Pythagorean Theorem. So I know if I've got my triangle here and this is 1 and this is x, how long is this? Well, x squared plus 1 squared, x squared plus question mark squared is equal to 1 squared. This is Pythagorean Theorem, right? So like if this is a, b, and c, you know how you would say a squared plus b squared equals c squared? Well, I'm just saying, so question mark squared plus x squared is equal to 1 squared. So then question mark squared is equal to 1 minus x squared. Question mark is equal to the square root 1 minus x squared. Now I can go back over here and plug in that this adjacent length is 1 minus square root of 1 minus x squared. So down here, my adjacent over hypotenuse, what's the cosine of theta? Well, cosine of theta is going to be square root 1 minus x squared over 1, which is square root of 1 minus x squared. So back to simplifying my derivative, I get that this fraction is equal to 1 over, and now what is cosine of sine inverse of x? It's going to be square root 1 minus x squared. Voila, there we have it. This is worthy of a rectangle because this is one of the derivatives that we needed to calculate, right? So let's get some practice with calculating other derivatives. let's do the same thing for cosine inverse. So suppose, okay, so remember our process is to let f of x, so now our goal is to figure out the derivative with respect to x of cosine inverse of x. Okay, that's our goal. So we're going to use our fact again about if you've got two functions that are inverses of each other, and we're just going to let f of x be cosine. So we're going to let f of x equal cosine of x, and g of x equal cosine inverse of x. Let me put in red here. We want to compute g prime of x, right? That's what this d dx is the derivative with respect to x of cosine inverse of x. So that's what we want. Okay, and now according to our formula, g prime of x is equal to 1 over f prime of g of x. Okay, but now let's see here. Our f of x is equal to cosine. So let's squeeze in and put in what is our f prime of x. F prime of x is equal to negative sine x. Okay, we remember that from Wednesday's lecture. So we can go ahead and fill this out. Now, how are we doing this? Okay, let me try to use a different color. Okay, so f prime of x is equal to negative sine x. So f prime of g of x is going to be negative sine of g of x. But what is g of x? G of x is cosine inverse of x. So we get negative sine cosine inverse of x. Now, so let's see here. So we've got our formula, which is going to be 1 over negative sine cosine inverse of x. Now again, we're going to be able to simplify this. So now let's simplify our formula. Right, so far we've got d dx of cosine inverse of x equals 1 over negative sine of cosine inverse of x. Okay, and our goal is we're going to simplify that. So all right, I want to show you this technique because it's really important and it comes up in calculus 2. So a lot of you are going to need to know this technique for next semester. And the technique is essentially you are simplifying expressions that involve trigonometric and inverse trigonometric expressions, or numbers you're evaluating, stuff like that. Okay, so first thing we want to do, so our goal is sine of cosine inverse of x equals what? That's our goal. So I'm going to draw my triangle and I'm going to set theta equal to cosine inverse of x. So this means cosine of theta is equal to x. Now I put my theta over here in the corner, and cosine of theta is equal to x, which I write as x over 1. Now this is the same thing as adjacent over hypotenuse. So adjacent is x, my hypotenuse is 1. Now I need to figure out what is this length here? What is the length of the other leg? And I use the Pythagorean Theorem. X squared plus question mark, or this little part squared, is equal to 1 squared. So question mark squared equals 1 squared minus x squared, which is 1 minus x squared. So I take the square root of both sides, and this length of the other leg is going to equal the square root 1 minus x squared. So I can now replace it with do. Okay, just erase it. And I've got, this is now square root 1 minus x squared. So sine of cosine inverse of x is going to be sine of theta. Remember, because we set theta equal to cosine inverse of x. And now what is sine of theta? I go back to my picture, and sine is going to be opposite over hypotenuse, right? Which is opposite over hypotenuse. So I get square root of 1 minus x squared over 1, which is just square root of 1 minus x squared. So that is sine of cosine inverse of x, square root 1 minus x squared. So this formula, 1 over negative square root 1 minus x squared. And this is a formula which is worthy of our box. Okay. And so, let's see here. So we can do one last example of this, which is the derivative of the tangent. So let's do one last example where we are now going to, our goal is to determine the derivative of tan inverse of x. Okay? So by now you're kind of used to it. Here's what we're going to do. We're going to let f of x equal tan x and g of x equal tan inverse of x. Then our formula says that g prime of x is equal to 1 over f prime of g of x. Okay? Now we know f of x is tan of x. So what is the derivative of tan x? Secant squared. F prime of x is equal to secant squared of x. So plugging this into our formula, we'll have 1 over secant squared g of x. Now what is g of x? G of x is equal to tan inverse of x. We'll have 1 over secant squared tan inverse of x. Okay, so now let's go to over here and we're going to simplify secant squared of tan inverse of x. So what I do, I set theta equal to tan inverse of x. That means that tan theta is equal to x. I draw my right triangle, put my theta down here. I get this angle here. So tangent of theta is equal to x. It's also equal to opposite over adjacent. So I'm just going to write x as x over 1. My opposite is x. My adjacent is 1. I need to figure out what is the length of the hypotenuse. And in order to figure that out, I use Pythagorean Theorem. X squared plus 1 squared equals question mark squared. Okay? So that means that question mark is just equal to the square root of x squared plus 1 squared. That's just the square root of 1 plus x squared. Question mark. So I can actually go in here and write down that this is going to be the square root of 1 plus x squared. All right. Now that I've got my triangle complete, I'm going to use it to calculate or to simplify secant squared of tan inverse of x. So let's see here. So secant squared of tan inverse of x is equal to secant squared of theta, because remember, we have theta is equal to tan inverse of x. That's how we set up our triangle, right? And now what is secant squared of theta? Secant squared is 1 over cosine squared of theta. And cosine of theta, so let me go to the side here, cosine of theta is adjacent over hypotenuse, which is 1 over square root of 1 plus x squared. Okay, so now cosine squared is equal to 1 over 1 plus x squared. Okay, and now 1 over cosine squared is going to be the reciprocal of cosine squared, so I just get 1 plus x squared. So this simplifies to 1 plus x squared, and I go back here, and I can rewrite this as g prime of x equals 1 over 1 plus x squared. So the derivative with respect to x of tan inverse of x is equal to 1 over 1 plus x squared. This is worthy of a red box. Now, for practice, you should make sure that you can derive the following other derivatives. So we just derived the derivatives for sine inverse, cosine inverse, and tan inverse, but we've got other formulas. We've got 3 other inverse trigonometric functions whose derivatives you should derive. So for homework, verify using method from this video that the derivative with respect to x of cotangent inverse x is equal to negative 1 over 1 plus x squared. And the derivative with respect to x of secant inverse x is equal to 1 over the absolute value of x times the square root of x squared minus 1. And lastly, that the derivative with respect to x of cosecant inverse x is equal to negative 1 over absolute value of x, square root x squared minus 1. So now what it will take to do this, you're going to use methods that are, this practice is going to be so important for Math 3B, about the second or third week, okay, when you're doing trig substitution. Okay, so go ahead and really practice this, especially if you know that you are going to be doing calculus. You're going to be doing more calculus. Okay, so now what I would like to do is I would just like to go through a couple of examples of actually using these formulas. So let's go through, this is, I guess, example 4. So now let us, which is to differentiate the following functions. All right, so let's see here. What are we going to do? So for part A, f of x equals sine x plus 9 sine inverse of x. Okay, so now when we calculate our derivative, f prime of x, we're just going to take the derivative of each part. So what's the derivative of sine x? The derivative of sine x is going to be cosine x. Now what's the derivative of, so we'll have plus, now we've got this factor here of 9. So that's going to, we're just going to write that down here, plus 9. Now we need the derivative of inverse sine of x, and that is, according to our formula, 1 over square root 1 minus x squared. So our answer is just this right here. F prime of x equals cosine x plus 9 over square root 1 minus x squared. Let's do another example. Example here is going to be example B. What about f of w equals w minus w squared times sine inverse of w? All right. So in order to do this, we're going to actually use the product rule first. So we've got to use the product rule. And remember, the product rule says if you have f times g prime, it's going to be f prime times g plus f times g prime. So we've got, so let's write down our derivatives here. So now if we're using this, so we would have, so using this formula, f of, actually not f of x, we'd have f of w. So we'd have f of w equals w minus w squared, and g of w equals sine inverse of w. Okay, f prime of w is going to be 1 minus 2w, because we're using the power rule, and g prime of w is just going to be 1 over the square root of 1 minus w squared. So putting that together, we need, so let's see here, let me try to use a different color. So we need
It's 8 o'clock. It's 20 hours.
this times this. So we'll have 1 minus 2w times sine inverse of w plus this times this. W minus w squared times 1 over square root of 1 minus w squared. So our final answer is f prime of w equals 1 minus 2w times sine inverse of w plus w minus w squared over square root 1 minus w squared. Okay. And let's do another example. We'll call this example C. This will be our last example. So for example C, we will have h of t equals secant inverse of t minus t cubed cosine inverse of t. So how do we find the derivative? Well, we'll need to use the, so here we'll need to use the product rule. Okay, so it's like f of t will equal t cubed, g of t cosine inverse of t. F prime of t is going to be 3t squared. G prime of t is going to be, well, let's see. Did we write our, okay. G prime of t, cosecant. Where's cosecant? Where's our formula for cosecant? No, cosine, sorry. 1 over negative square root, right? 1 over negative square root 1 minus x squared. Okay. Hopefully I can remember that. So I can just write negative 1 over square root 1 minus t squared. Okay. Here I need the derivative of secant. So the derivative of secant is going to be, let's see here, secant inverse. 1 over absolute value of x times the square root of x squared minus 1. 1 over absolute value of x times square root x squared minus 1. And now I'm going to change the x to a t because that's what we're working with. So it's absolute value of t and then t squared minus 1. Okay, so now I believe I'm ready to put it all together and say that h prime of t is equal to, so I need the derivative of secant inverse of t, which is 1 over absolute value of t times the square root of t squared minus 1. Okay, minus, now I'm using my product rule. Remember using the product rule. So I'm going to say 3t squared times cosine inverse of t plus t cubed times negative 1 over square root 1 minus t squared. Okay. So all of this needs to be rewritten. So this I'm going to rewrite as negative t. Let me see. Let me try to copy this because it is a hot mess. Copy. Paste. Okay. So now h prime of t equals, so I have 1 over the absolute value of t times the square root of t squared minus 1 minus 3t squared cosine inverse of t. And then the minus and this minus are going to cancel each other out, and it's going to turn into plus t cubed over square root 1 minus t squared. And there we go. Thank you.